Okay, so in this video we're going to have a look at deriving this particular trigonometric equation here. Sine of an angle A of the angles A plus B is equal to sine of the angle A times the cos of the angle B plus the cos of the angle A times the sine of the angle B. Now, in order to do this, what we're going to do first is start with this particular trigonometric identity here. Now, we've proven this or derived this particular equation in a previous video, so you can have a look at that if you like, but we're going to start with this particular one here. The cos of A minus B is equal to cos of A cos B plus sine A sine B. Okay, so we're going to start with this. We're going to develop this. We know that this is true, we proved it earlier, so we're going to develop this until it looks like this up here. Okay, so the first thing we're going to do, the first thing you've got to remember what to do is change the A. Instead of the angle A here, we're going to change that into 90 degrees minus A. Or we'll use radians. We'll say pi over 2 minus A. So I'm just going to write that in first of all. So instead of the A then, so we got cos. Instead of the A here, we're going to put in pi over 2 minus A. And you'll see the reason for this later on. We've got a minus B then. Here we've got cos, and remember the A here, that's being replaced with pi over 2 minus A. And we've got cos B here, plus sine of A, so the A then is replaced again with pi over 2 minus A, and we have sine B here. Okay, so all we've done simply is started with this, and we've replaced the A with pi over 2, or 90 degrees, minus A. Now, I'm just going to take a little side step here and just have a look at this triangle here. Talk about this right angle triangle here, and we'll say this is the triangle ABC. So this is our angle A here, and this is our angle B, and our angle C here is 90 degrees. Okay, so if that's the angle A, then this over here is the side A. If this is the angle B, or the vertex B, this is our side B, small b, and if this is the angle C here, this is small c over here. Now if you have a look at this angle here is 90 degrees, and this is A here. This is the angle of size A here. So this angle here is the remaining angle. Now remember, the three angles of a triangle add up to 180 degrees. This is 90 degrees, so that means the angle A plus this angle here must add up to 90 degrees. In other words, this angle here then must be 90 degrees, or pi over 2 minus A. So that angle there is 90 degrees, or pi over 2 minus A. And that's why we put that in here. But let's have a look at that a little bit further. Okay, now let's look at the sine and the cos of our angle A here. The sine and the cos of this angle A here. So let's look at the sine of A. First of all, the sine of A is going to be the opposite over hypotenuse, which is A over C. That's the sine of A. The cos, or the cosine of A, is going to be adjacent over hypotenuse, which is B over C. Now let's also look at the sine and the cos of our angle B here. So the sine of our angle B, which is pi over 2 minus A, this is our angle B here. Sine, remember, is opposite over hypotenuse. Now the opposite here is going to be this side here. So it's going to be B over the hypotenuse, which is C. The cosine of our angle B here, or pi over 2 minus A, the cosine of pi over 2 minus A. Cosine, remember, is adjacent over hypotenuse. Now the adjacent to this particular angle is here, so that's A over C. Now let's have a look at these four for a second. If you look at these four, you'll see that the sine of A is A over C, and the cos of pi over 2 minus A is also A over C. So these two here are actually equal. So the sine of A is equal to the cos of pi over 2 minus A. Similarly, you can see that the cos of A is B over C, and the sine of pi over 2 minus A is also B over C. So in other words, these two here are equal. So we can say then that the sine of an angle A is equal to the cos or the cosine of pi over 2 minus A. We can also say that the cosine or the cos of A is equal to the sine of pi over 2 minus A. So we're going to use these two equations here now. We see we have a cos of pi over 2 minus A. We know that that's equal to sine of A. So instead of this here, we can write sine of A. We have a sine of pi over 2 minus A. We know that that's equal to cos of A. So instead of this, we can write in cos of A. So that's what I'm going to do down here. So I'm going to just come down here now, and I'm going to write this down again. So I'm going to write down cosine of pi over 2 minus A. I'm not going to do anything with the left-hand side yet. Is equal to cos pi over 2 minus A. Look, cos of pi over 2 minus A we know is equal to sine of A. So I'm just going to write down sine of A instead of that. Cos B plus sine of pi over 2 minus A. Sine of pi over 2 minus A we've discovered is cos of A. So I'm going to write that down here. Cos of A sine B here. Okay, so we've sorted out the right-hand side. And you can see that the right-hand side is what we want to end up with. Sin A cos B plus cos A sin B. Sin A cos B plus cos A sin B. So that's exactly what we were looking for. Now, the left-hand side doesn't look like this here yet, sin of A plus B. So let's see if we can convert the left-hand side. Okay, now, what I'm going to do here is just change around what's inside the bracket here. So I'm going to write down cos. Take away the bracket here, you end up with cos of pi over 2 minus A minus B. And that's equal to sine A cos B plus cos A sin B. Same, well, we're not doing anything more with the right-hand side. Now the left-hand side then can be changed around again to look like this. Cos of pi over 2 minus, and we can put the A minus B in bracket, but I need to change it to A plus B because this minus will change this to a minus, which is exactly what we want, and minus times plus will give us this minus here. So this is exactly the same as this, which is exactly the same as this. So all I've done really is move the brackets from here over to here. Okay, and the right-hand side remains the same. Sine A cos B plus cos A sin B. Okay, now, if you look at this here, this is similar to what we've done up here. This is similar to this bit up here. We have cos of pi over 2 minus an angle, and the angle here happens to be a composite angle, if you like, A plus B. So this is like the cos of pi over 2 minus some angle, and we know that the cos of pi over 2 minus some angle is just the sine of that angle. So instead of cos pi over 2 minus A plus B, we can just simply write down sine of A plus B here. The cos of pi over 2 minus an angle is equal to the sine of the angle. So on the right hand side we have sine A cos B plus cos A sin B. And this is exactly what we were looking to prove from the very beginning.